What's up, guys? This is Mr. Ollie from down the hallway, here to help you out with our new idea for today, which is inscribed angles. Now, think back to last week. Last week, we learned about central angles. Central angles were angles inside of a circle where, if you take a look here, we created an arc from two radii, meaning we connected points on the outside of the circle to the center. And that became our vertex, right? Felt pretty good about that. What happened was, once we've created an angle, a central angle inside of our circle, it also created an arc on the outside of the circle, which is just a portion of the circumference, right? And from there, we knew that whatever this angle was here, let's call it x, the angle on the outside was the same measure, x degrees, right? That was a central angle because it was created in the center, right? Today, we're learning about inscribed angles, which is going to be a slightly different. Instead of, let's go back, instead of having radii creating the sides of our angle on the inside of a circle, now you're going to have chords creating the sides of your angle created inside of the circle. Once you have two chords together, meeting at one point called the vertex, things are going to double for our arc. You see, once we have our two chords creating an angle, this is the result. An inscribed angle is an angle with its vertex on the circle. Again, point B is on the circle, and that's now where we're going to create our angle. The two sides are chords, like I just explained. But now, an intercepted arc is the arc that lies between the... the other 2 points are also on the ends, just like they were before. That's what's creating the chords, the fact that these 2 points are on the ends, okay? Now, here's where the difference comes in. Once we've created these two chords and connected them, what happens is the angle that has now been inscribed inside of the circle, this angle here, is actually only going to equal half of the measure of the intercepted arc AC here, okay? This angle here, angle ABC, is only going to equal half of our outside arc here, AC. AC is going to be twice as big as the angle inscribed. The inscribed angle is half the size, and so we can write out our formula or our equation like this. The measure of angle ABC right here is equal to half of the measure of our outside arc created, okay? The way I like to think of it is not necessarily that this is half the size of this, right? Okay, so here's an example. If the arc is, I don't know, 44 degrees, okay, it's probably a little bit bigger than that. Or yeah. If the arc is 44 degrees, then we know that this angle inscribed, or the inscribed angle, is half of that. Half of 44 is 22 degrees, right? But I also like to think of it the opposite way. The opposite way is to say that the arc is twice as big as the inscribed angle. So if this angle was, we'll be more realistic, okay, let's say this is 30-degree angle, right? If this angle is 30 degrees, then this arc out here would be twice as big, or it would be 60 degrees. That's the whole idea with an inscribed angle. Now, some things happen that are unique when you do have an inscribed angle that has one side that's a diameter. You see, if we're creating an inscribed angle with two chords, AB and CB, but this chord here, CB, actually ends up being a diameter going all the way across. The longest type of chord is a diameter. It goes through the center. Well then, what we get out of that is that a right angle is now created on the inside. The inscribed angle is intercepted with a diameter, or intercepts a diameter, then it is now a right angle here, okay? Meaning angle BAC, right here, it's got a little box now, it's equal to 90 degrees. So remember, diameter goes through the center point. Okay, that's just something I put there as well, okay? But again, if you have a diameter as one of your chords, well then this angle should be 90 degrees, which makes sense because this angle is 90 degrees, which is half of our arc CB. But since it's a diameter, you know that this arc is equal to 180 degrees. So it makes sense that this angle inscribed is 90 degrees, right? Because a diameter is equal to 180, then this outside is also equal to 180 because it's twice the size. And so half of that would be 90 degrees. That's why when you have a diameter, your angle inscribed is now 90 degrees. Whoops. Lastly, if you have two inscribed angles that are creating the same arc, right? So let's take a look. We have ABD and DBA. Well, you'll notice they both have endpoints at AD. AD are the two endpoints for ABD and DCA. So since they share the same endpoints, they create the same arc. So if they're creating the same arc, that must mean that they're equal, right? These two angles on the inside must be equal because they're creating the same arc. So half of this arc would be the same angle here for DCA and for ABD. Again, if this was 72 on the outside, then this would be 36, and this other angle would be 36, right? So then they're equal. Another way to write that is that the measure of angle ABD is equal to the measure of angle ACD. ACD, ABD. I said DCA, whatever, but same thing. Hopefully that helps you out. Now, let's try some examples.